Hello everyone, welcome to Algo-holic, the place where you learn not just the solutions but the thought process behind solving problems. Today we are solving the problem remove element. We are given an integer array nums and an integer val. We are supposed to remove all occurrences of val and this has to be done in place. The order of the elements may be changed, so in the final array the order doesn't matter, and we are supposed to return the number of elements in nums which are not equal to val. What does this mean? Let's say we have an array like this and we're supposed to remove 3. We pop it out and the final array looks like this. Since it has 3 elements, we just return 3. This is the gist of the problem and this just talks about how your code will be judged. Let's look at an example. So we have 3, 2, 2 and 3 and we're supposed to remove all 3's. After you remove all 3's, this is what the array is going to look like. So this just means that whatever comes over here, it doesn't matter. We just return 2, which tells the algorithm to just check for the first 2 elements of our array. This is what we're supposed to do. By just looking at this, you might have gotten an idea of how to approach this, but let's try to approach it from the brute force solution and get to the final solution. So the brute force solution here would be to just call the remove function. There is a built-in function in Python, C++, and Java where you can just call remove and mention the val, in our case 3, and it's just going to remove. So what happens under the hood when you do this? We use the same example, and when we call the remove function on 3, 3 will be popped out and 2 will be copied to 3's position. This would go over here and 3 would go over here. Now, why is this done? In the memory, when we declare an array, let's say these are different memory locations and our array starts over here. This is the 0th index, first index, second index, and goes on. Let's say we remove this. If we remove this using the built-in function, we cannot just let it be because that index is no more accessible. So to make sure that it still holds all the properties of an array, we're supposed to copy this to here so that when we still call the index 1, we still have a valid answer. So that is why when we call a remove function, all the elements inside the array, which is towards the right of the element, gets copied towards the left. So what is the time complexity of this? Well, just the removing is just O of 1, but each copy operation takes O of 1 as well. So if you remove the first index, that's going to be O of n. If you remove the last index, since there is no copying to be done, it's just O of 1. When you take the average, it's O of n by 2, which we can round it up to O of n. Now, what is the worst case scenario? The worst case scenario is the whole array is just 3. In that case, it's going to become O of n into O of n, which is n squared, which is not a good solution. But we at least got to the solution now. This is a working solution. It's a bad solution, but it still works. Now, how do you optimize this? Well, instead of just removing the elements directly, what if we could just put the element in that part of an array which doesn't matter? This is what you would have noticed over here. Since the last elements of the array doesn't really matter, what if we just put all the values in the end of the array? So let's see how that would work. Let's say we have an array 1, 2, 1, 3, and 4, and we're supposed to remove all the ones over here. So let's just transfer all the ones towards the right. Now, how do you do that? Let's initialize one pointer, let's say I and j. Now let's see if we encounter 1. If we encounter 1 when we are at the ith index, we transfer it to the jth index. And we keep incrementing and decrementing both the pointers, and we stop once these pointers meet. So now, since I has already found 1, we swap I and j. So the new array is going to become 4, 2, 1, 3, and 1. J is still over here and I is over here. Now we need to update j as well, because if we encounter another I, if we encounter another 1, this 1 will get replaced back. We don't want that. Now this should be permanent, and the only way to make it permanent is to decrement j. So once we decrement j, j is going to be over here. Now is I equal to 1? It's not. So let's just move I over here. Now I is pointing towards 2. Is again I equal to 1? It's not. So let's move it again. Now I is pointing towards 1. Now I is pointing towards 1 and j is not pointing towards 1. We swap it. So the final array is going to look like 4, 2, 3, 1, and 1. Now what do we do here? We just return 3, which is one value minus j, by the way. So why are we returning 3? These are the elements which are not equal to val, and it doesn't matter what is in the rest of the array, because the testing algorithm is not going to look at what's after 3 in this case. So this is the most optimal solution. What is the time complexity of this? Well, we just move I from left to right and move j from right to left, and we stop once I and j meet. So that's O of n. And swapping again takes just O of 1. So even if all the elements were, even if we have to swap half of the elements in the array, that is still going to be O of n itself. So the time complexity is O of n, and we are not taking any extra space. Let's quickly code up the brute force solution. So here we need to check if val is present in nums before we call the remove function. So we repeatedly check if val in nums, and if it is, we just call the remove function. Now, if you're using C++ or Java, there's a direct method that you can call called remove all, where it removes all occurrences of the value. But since Python does not provide with that, we just have to use the while loop. So in the end, we just return the length of nums. Yeah, this works. It's a pretty simple solution to come up with. Now let's look at the optimal solution. There is two ways to go about this. One is where you initialize I pointer at the beginning, you initialize the j pointer at the end, and you swap when you encounter val. Another approach is where you initialize I and j both at the beginning, and you swap when you don't encounter val. Now, the time complexity of both the approaches remains the same, but the code is much more cleaner when you implement the second one. So that's what I'm going to show you right now. I'll just show you how it works in theory. So let's say we have an array like this, 3, 2, 2, 3. We initialize I and j over here. I would be the slow pointer, j would be the fast pointer. Now let's check if j is equals to val. Does it equal to val? Now j is equals to val, so we're not going to swap. We're just going to move the j pointer. Now is j equals to val? J is not equal to val. Now we are going to swap it. So we swap I and j. It becomes 2, 3, 2, and 3. We increment both the pointers I and j. So I is over here and j is over here. Now is j again equal to val? J is not equal to val, so we swap again. So the final array becomes 2, 2, 3, and 3. This would go on for another iteration, but nothing is going to change. So this is the final array, and we just have to return the slow pointer. So let's see how this would look. Slow equals 0 and fast in nums. So now we are supposed to check for the value. So if nums fast is not equal to val, we swap it. So nums slow equals, and we increment the slow pointer. We don't need to increment the fast pointer over here because it's already in the for loop. So we can just go ahead and return the slow pointer. Yep, it works. Let's just make sure that this is the most optimal solution. Yes, this is the most optimal solution. The code in C++ and Java looks pretty much the same, where we have a for loop, we just loop till the end of the array. We check if we encounter val, and if we don't encounter val, we just swap it and we increment the slow pointer. Java code looks, I think, exactly the same, where we have a for loop, we make the swap, and we return the slow pointer. So that's all for today. I hope you found this video helpful. Your feedback helps me make better content, so please share your thoughts in the comments below. I'll see you in the next video.